with its unique features and the life it hosts within, is truly a very special and one-of-a-kind planet. The Earth, which is home to many different characteristics and mysterious structures, has a neighbor that is just as interesting as itself. Although how it was formed is still not fully clear, it has a story that is accepted by the entire world: the Moon. When viewed from a space-time perspective, the Moon is actually not a satellite that formed long after the Earth. It was formed around the same time, during the period when the Earth had either completed or was just about to complete its own formation. Today, together, we will talk about our satellite, the Moon, which shows itself every night in the sky and captures the eyes of many people. But before we move on to our video, don't forget to subscribe to my channel and like my videos to support me. Now, if you're ready, let's go far back in time, 4.6 billion years ago, to when our solar system first began to form. About 4.6 billion years ago, there was no solar system as we know it today. There was only a massive cloud of gas and dust. Inside this cloud were the elements that would become the building blocks of many structures within the system: hydrogen, helium, iron, nickel, and carbon. At one point, a part of this cloud began to collapse under its own gravity. This collapse was the beginning of the process that would lead to the birth of the sun. While the sun was forming in the central part, gas and dust particles spinning around it like a CD began to clump together over time. Within this disk, colliding particles stuck to each other, gradually growing larger, and eventually formed what we call planetesimals, the precursors to planets. One of these forming planetesimals was, of course, the early version of our Earth. At that time, the Earth was nothing like it is today. It was made entirely of hot, molten rock and metals. The surface was like hell itself. Volcanic activities were extremely intense, and since there was no protective atmosphere like today's, the planet was constantly bombarded by meteorites. Also, as the constantly erupting Earth took shape, its atmosphere was not like the one we have now. It was full of carbon dioxide, water vapor, methane, and ammonia. However, over time, with the heat coming from within and external collisions, the internal structure of the Earth began to separate into layers. Heavy elements sank toward the center, while lighter elements rose to the surface, thus forming the core, mantle, and crust. During this process, the Earth's magnetic field also began to take shape, which later became one of the most important shields protecting our atmosphere and surface from the deadly radiation coming from the sun. The event that would give our Earth a new companion took place about 4.5 billion years ago. A Mars-sized planetary body called Theia collided with Earth. The impact was so massive, so powerful, that an enormous amount of material was ejected into space at the moment of impact. This is where our satellite, the Moon, began to form. But I'll get back to that later because I want to talk a little more about our planet's formation. Anyway, after this collision, our planet once again melted completely, just like in its early days. Fortunately, over time, it began to cool down, and the lava on the surface solidified. In this way, the first rocks on our planet were formed. Then the gases released by volcanoes condensed, forming a primitive version of today's atmosphere, the early atmosphere. This atmosphere was initially full of toxic gases, with almost no oxygen. But as the Earth cooled, ice and water vapor brought by meteorites condensed and formed the first oceans. Over time, volcanic activity gradually decreased. The sky became calmer, and with the sun's energy, the first chemical reactions began on our planet. And then came that magnificent moment. Thanks to these reactions, the first traces of life began to appear. Simple microorganisms. Later, these organisms started producing oxygen, and the Earth became a more suitable environment for other forms of life. As more and more living creatures began to appear, our planet became increasingly habitable, and the population of life on Earth grew day by day. Then after billions of years passed, it took the form we see today. Unfortunately, it seems that we humans are now trying to return the Earth to its old primordial days by harming every part of our planet. We are damaging its vegetation, its animal life, its atmosphere, its underground resources. In short, everything. I wanted to mention this because, even if we don't realize it, the damage we're causing will one day force us to fight against nature itself. And whether we win or lose that fight, the loser will still be us. In short, it's a situation that harms us either way. The best thing we can do is to avoid interfering too much with nature and instead help it renew itself. Anyway, let's move on to the main topic of our video, our beautiful and unique moon. As we mentioned earlier, about 4.5 billion years ago, a planet-like object collided with Earth, throwing a vast amount of material into space. Millions of tons of molten rock, metal, and dust began orbiting around our planet. At first, this debris looked like a ring, much like Saturn's rings. But over time, these pieces started colliding and merging together. The heavier ones sank to the center, while the lighter ones rose to the surface. And from this cosmic ring, our moon was born. When the moon first formed, it was much closer to Earth than it is today. If it had stayed at that distance, we would probably be able to see every crater and mark on its surface with the naked eye. As you know, the moon's gravitational pull creates tides on Earth, causing the oceans to rise and fall, generating massive waves, tsunamis, and even earthquakes. In its early days, when the moon was closer, these effects were far stronger. In fact, the tides were so extreme that the oceans could move hundreds of kilometers back and forth. These enormous tidal forces gradually slowed down Earth's rotation, and over time, the moon began to drift away from us. Many people don't know this, but our moon moves 3.8 centimeters farther away from Earth every year. This might sound like a small amount, but time passes quickly, and this slow drift could have major effects in the future. Perhaps 5 to 10 generations from now, people will only be able to see the moon through telescopes and in historical records. When you think about it, we are incredibly lucky. We are the generation that can still look up and see the moon with the naked eye, even spotting its craters and impact marks if we pay attention. The process of the moon's formation also determined its physical structure. The moon's internal structure consists of 3 layers: the crust, the mantle, and the core. Its core is small and dense, made mostly of iron. However, unlike Earth, the moon's core is no longer active, meaning it doesn't have a magnetic field. Because of this, radiation from the sun directly reaches its surface, leading to extreme temperature differences. To give you an idea, daytime temperatures on the moon can reach up to 120 degrees Celsius, while at night they can drop to minus 170 degrees Celsius. That's such an incredible difference that, if the moon had an atmosphere and these temperatures remained the same, it would experience intense weather events. And since we're so close to it, we would be able to watch those events with great curiosity and excitement. When we look at the moon's surface and see that gray, cratered landscape, what we're actually seeing are the scars of countless meteor impacts over millions of years. Our moon looks like a warrior who has survived countless battles, carrying those marks as proof of its endurance. It's no wonder that so many emotional poems, stories, and legends have been written about it. Everyone who looks at the moon sees something different. Every perspective gives it a new meaning. Anyway, the reason the moon has been hit by so many meteors is that it has almost no atmosphere. As I mentioned earlier, this thinness means there are no weather phenomena at all. But beyond the myths and stories, scientists sometimes use the moon as a historical record, because every crater and every depression is like a memory from billions of years ago. By studying these craters, scientists can uncover and analyze ancient events that also affected Earth. If you've noticed, some regions on the moon's surface appear darker. These areas are called Maria, which means seas. They were given this name because they were once vast lava plains, formed by ancient volcanic eruptions billions of years ago. The moon's soil is called regolith, and it's made up of microscopic, glass-like dust created by countless meteor impacts over millions of years. This soil is extremely fine, so fine, in fact, that if an astronaut's suit has even a pinhole-sized opening, the dust can enter and damage many parts of the suit. Regolith gives the moon its grayish-white appearance. Interestingly, this soil is unlike any material found on Earth. It's sharp-edged, electrostatic, and sticky. That's why astronauts' suits get completely covered in dust after walking on the lunar surface. Another strange feature of our moon is a phenomenon called tidal locking. This means that the moon's rotation period on its axis is the same as its orbital period around Earth, so the moon always shows us the same face. That's why people came up with the idea of the dark side of the moon. Contrary to popular belief, that side isn't always dark, we just never see it from Earth. However, interestingly enough, many spacecraft that have crossed to the far side of the moon have experienced malfunctions and communication problems. In other words, the devices sent there often lose contact with us or experience serious technical difficulties. Another topic that scientists and the general public have been debating for many years is the presence of water on the moon's surface. Whether there is water on the moon has been a matter of discussion for decades, but recent research has revealed that in the polar regions, especially in craters that never receive sunlight, There is water in the form of ice. This discovery is extremely important for the future of human bases and colonies that may one day be established on the moon, because that water can be used not only as drinking water, but also split into hydrogen and oxygen to produce fuel. The moon is not just a geological remnant, it also plays a vital role in shaping life on Earth. Without its gravitational pull, Earth's axial tilt would eventually become unstable, and our seasons would change drastically. We might have had much harsher and colder winters, or the complete opposite, unbearably hot temperatures that would make life impossible. This instability could have also made the evolution of life nearly impossible. When you look at it from this perspective, the moon acts like a cosmic balancing stone, maintaining Earth's equilibrium. Additionally, thanks to the tides created by the moon's gravitational influence, our oceans are constantly in motion. This movement created the perfect conditions on early Earth for chemical reactions that laid the foundation for life to begin. In short, without our moon, there might never have been life on Earth. Or if there had been, it might have remained at the level of the simplest microorganisms, unable to evolve any further. When you think about it, for many people, the moon may just seem like another celestial body. But in reality, it's one of the fundamental building blocks of our existence, our planet, and all living things. If the moon didn't exist, life would have faced unimaginable challenges. In its earliest days, the moon was a blazing, terrifying ball of fire. But over time, it became a source of beauty and balance. Almost like a flower blooming in the darkness of space. Those of us who are curious about space, who wonder what's happening out there, often focus on distant worlds. But we should also look more often at the one right beside us, our moon, and let our imagination wander. In short, the moon equals Earth and Earth equals us. If you're like me, curious about space, the universe, and all these cosmic wonders, and you want to support me, don't forget to subscribe to my channel and like my videos so they can reach more people. That's all from me for today. Now I'm off to search for new ideas for my next video and to find reliable sources for those ideas. See you in the next video. Each and every one of you is truly valuable to me. Until then, take care and goodbye.